Today we'll be working on exponents, roots, and radicals, part 2. In our previous video, we talked about taking something to its square. So, for example, if you had 2 and you raise it to the second power, that would be multiplying 2 times itself. So in this video, we're going to talk about the inverse of squaring numbers, which is to say, taking the square root of it. So say you had the square root of 4. In order to simplify and solve this, we're looking for the perfect square of 4, which is to say, what times itself gives us 4. So in this case, 2 times 2 gives us 4. Or we can rewrite this as 2 squared. So if square roots and squares are the inverses of each other, then 2 squared, if we take the square root of it, is just going to be 2. So in the same way, if we had the square root of 144, then we're going to be looking for perfect squares in order to solve. So we know, based off of our multiplication tables, that 144 is 12 times 12, which we can also write as 12 squared. So simplified would just give us 12. Similarly, if we had the square root of 18. This one isn't going to simplify as neatly though, but we're going to start by looking for its factors. So we can say 18 is 9 times 2, and we know that 9 is a square root. If we simplify that, we get 3 square root of 2. We know that 9, we can simplify this because 9 is equivalent to 3 times 2, or we can write it as 3 squared times 2. However you prefer to go about it, simplifies down to the same thing. Say you had a really big number, like the square root of 264. I don't know its factors right off the top of my head. I'm guessing you don't either. So I can't pull out a square root or a perfect square of this. So your best strategy is to take your number, 264, and start breaking it down into its factors. In this case, we could break it down into 2 times 132, and that's not a perfect square yet, so we want to keep breaking it down. So factors of 132 are 2 and 66. And that's not a perfect square, so we're going to keep breaking it down into 2 and 33. And 33 doesn't have any perfect squares in it. But if we look, we've gotten ourselves 3 2's, and we only need 2 of those to pull out and simplify. So we're going to rewrite the square root of 264 as 4 times 2 times 33. So we can pull out 2, and we're left with the square root of 66. Alright, say you have something like the square root of 32. Again, we would want to take our 32 and break it down into its factors. So 32, factors of 2 and 16. And we know 16 is a square root. It's 4 times 4. So we can write this many different ways. We can write this as the square root of 16 times the square root of 2, which gives us 4 square root 2. You can write it as 4 squared times 2, which gives us the square root 4 square root 2. You can write it as 4 times 4 times 2, which will still give you 4 square root 2. Alright, so let's look for something like the square root of 27. So we begin by breaking down 27 into its factors. 9 times 3 is equal to 27, so let's use those. And 9 is a perfect square, so we can go ahead and simplify this as 3 square root of 3. So say you were looking for what we call the cube root. What's the cube root? Well, if the square root is looking for something times itself twice, then the cube root is looking for something times itself 3 times. So it's the inverse of raising something to the third power. So say you were looking for the cube root of 16. Similar strategy, we're going to take our 16, we're going to break it down into its factors. 16 is a multiple of 2 and 8, and if we break it down completely, we see that 8 is really just 2 to the third power. 2 times 2 times 2. So we can rewrite the cube root of 16 as cube root of 2 to the third power times 2, and then from there we see it simplifies down into 2 cube root of 2. Let's do another cube root problem. Say you're looking for the cube root of 54. Same strategy. We would look for factors of 54. So let's try breaking up 54. Let's see. Two times 27 is equal to 54. And we know that 27 is cube root of 3, so we can simplify this to 3 cube root of 2. If we want to really prove it to ourselves, we can take 27 and break it down into its factors. 27 is 3 times 9. 9 is 3 times 3. So we can see that 3 raised to the third power is equal to 27. You can do this process for any power. Say we were looking for the fifth root of 96. Well, we would start by taking our 96 and getting our factors. So 96 is a factor of 2 and 48. 48 breaks down into 2 and 24. 24 breaks down to 2 and 12. 12 breaks down to 2 and 6. 6 breaks down into 2 and 3. So if we count up our 2's here, let's take a look. We've got 1, 2, 3, 4, 5. So we can rewrite the fifth root of 96 as fifth root of 2 to the fifth times 3. And from here, we can simplify 2 the fifth root of 3. Say you were multiplying two radicals together. Say we had the radical of 6 times the radical of 6. First, you would put everything underneath the radical sign. So we would have 6 times 6, which is equal to radical 36, which simplifies down to 6. You can also write it as the radical of 6 squared, and from there simplify down to 6. Say you are multiplying the radical of 12 times the radical of 18. Again, we will put everything underneath our radical sign, so we've got 12 times 18. Alright, and let's break this down into our factors. So, if we break down our factors completely, we know that 12 is equal to 2 times 2 times 3. We know that 18 is equal to 2 times 3 times 3. Alright, so as we can see, we can simplify this down into 2 to the third power times 3 to the third power. And with the power of exponents, we can also rewrite this to be 2 times 2 to the second power times 3 to the second power. And right there, we could pull those two squares out. So we could pull this 2 to the second power out. We could pull this 3 to the second power out. So that would give us 2 times 3 square root of 2 times 3. Which gives us 6 square root 6. Alternatively, you can simplify from here. We know that 2 squared is 4, and we know that 3 squared is 9 times 2 times 3, which gives us the square root of 36 times 6, and 36 we know is a perfect square, so this simplifies down into 6 square root 6. And that about covers it for exponents, roots, and radicals this time around.